Imagine a factory floor stretching the length of several football fields. Robotic arms move with surgical precision. Autonomous vehicles glide silently between stations. Conveyor belts hum with activity, and not a single human being in sight. No workers, no supervisors, no lights. This isn't science fiction. This is happening right now in facilities across China, Japan, Germany, and increasingly, the United States. They're called dark factories, and they represent the most significant shift in manufacturing since Henry Ford invented the assembly line. Today, we're going to explore how these autonomous facilities are reshaping global supply chains, why they could eliminate 12 million jobs in China alone by 2030, and what this means for the future of work and the global economy. Let's dive in. A dark factory, also known as a lights-out facility, is a production site where machines handle every task: assembly, inspection, logistics, quality control, all of it automated. The term dark comes from a simple fact. Without human workers, there's no need for lighting, no need for heating or air conditioning, no break rooms, no parking lots filled with employee vehicles, just machines operating around the clock in conditions optimized entirely for efficiency. Now, the concept isn't entirely new. Fanuc, the Japanese robotics giant, has operated lights-out facilities since 2001, where robots build other robots with minimal human oversight. But what's changed is the scale, the sophistication, and the speed of adoption. In Beijing, Xiaomi has built a fully autonomous smartphone factory, capable of producing a device every 3 seconds. The entire manufacturing process, from assembly to testing, is handled by AI-driven machines. That's not a pilot program, that's full-scale production. Foxconn, the company that manufactures devices for Apple, replaced over 60,000 workers at its Kunshan factory with robots back in 2016. The company aims to automate 30% of its total operations within the next few years. Siemens operates an electronic manufacturing plant in Amberg, Germany that reports a quality rate of 99.99%. Not 99%, 99.99%. That level of precision is nearly impossible with human workers alone. So how do these facilities actually work? What makes a dark factory possible? The answer is a convergence of several technologies that have matured simultaneously. First, advanced robotics. We're not talking about the simple mechanical arms of the 1980s. Modern industrial robots feature multiple degrees of freedom, force feedback sensors, and the ability to handle delicate components without damage. Collaborative robots, or cobots, can work alongside the few humans who do enter these facilities for maintenance. Second, artificial intelligence. AI functions as the factory's brain, directing robot movements, analyzing data in real time, and making continuous adjustments to keep systems efficient. Machine learning algorithms predict when equipment will fail, schedule maintenance before problems occur, and optimize production flows based on real-time demand. Third, the Internet of Things. Sensors are embedded throughout these facilities. They monitor temperature, vibration, humidity, and thousands of other variables. These sensors collect and transmit data constantly, creating what engineers call a digital twin, a virtual replica of the physical factory that allows operators to simulate changes and optimize performance without risking actual production. Fourth, autonomous mobile robots. These aren't stationary machines. Automated guided vehicles and autonomous mobile robots move materials across factory floors, reposition tools, and deliver parts exactly where they're needed. In one Chinese auto factory, these mobile robots have cut logistics time by more than 40%. And fifth, connectivity infrastructure. All of this requires extremely reliable, high-speed communication networks. The emergence of 5G and soon 6G technology provides the bandwidth and low latency needed to coordinate thousands of machines in real time. If that connection fails for even seconds, the entire system can grind to a halt. No country has embraced dark factory technology more aggressively than China. In 2022, China installed 290,367 industrial robots. That's 52% of the entire world's total, more than the United States and Japan combined. China's robot density, the number of industrial robots per 10,000 workers, reached 392 in 2023. For context, the global average is 141. Germany sits at 415, the United States at 274. This transformation is driven by China's Made in China 2025 initiative, a national strategy to make the country a global leader in high-tech manufacturing. The government invested $1.4 billion in robotics research and development in 2023 alone, along with substantial subsidies to promote AI and smart factory adoption. But it's not just policy. Economics are driving this shift as well. China's labor costs have risen significantly over the past 2 decades. At the same time, an aging population means fewer workers entering the manufacturing sector. Automation becomes not just attractive, but necessary. Companies like BYD, the electric vehicle manufacturer, have installed robotic systems across their battery and vehicle body manufacturing lines. Their facilities in Shenzhen and Xi'an are moving closer to full lights-out operation with each passing year. The International Energy Agency estimates that industrial automation like this can lower energy use by 15 to 20% by eliminating human-centric infrastructure needs. China's National Bureau of Statistics actually reported a 1.7% drop in industrial energy consumption in 2022, partly attributed to automation gains. But here's where things get uncomfortable. A 2017 Oxford economics report projected that 12 million Chinese manufacturing jobs could disappear by 2030 due to automation. Manufacturing currently employs over 100 million people in China. That's 12% of the workforce at risk. And China isn't alone. In the United States, nearly 500,000 manufacturing jobs remain unfilled right now. Not because workers don't want them, but because modern factories require digital, robotics, and AI skills that current training systems cannot supply at scale. The Manufacturing Institute found that 5 out of 10 open positions for skilled workers remain unoccupied today due to the skills gap. The jobs that exist are fundamentally different from the jobs being eliminated. A 2023 strike in Guangdong, China, highlighted by the China Labor Bulletin, showed workers' genuine fear of robotic replacement. Similar anxieties are emerging in manufacturing hubs worldwide. The question isn't whether automation will transform the labor market. It already is. The question is whether societies can adapt quickly enough to prevent massive displacement. This brings us to one of the most fascinating collisions in modern economics. Reshoring meets automation. For decades, companies offshored manufacturing to countries with lower labor costs. China became the factory of the world. But recent disruptions, the pandemic, geopolitical tensions, supply chain chaos, have forced businesses to reconsider. Now, 95% of U.S. industrial businesses plan to roll out new automation within the next 3 years, according to recent research from Robco. Nearly half already use some form of AI-powered automation today. The logic is compelling. If robots do the work, labor costs matter less. A factory in Ohio using autonomous systems can compete with a factory in Shenzhen. But there's a catch. U.S. labor averages $25 to $30 an hour compared to roughly $6 to $7 in China. Even with automation, rebuilding domestic manufacturing requires enormous capital investment, supplier networks that take years to develop, and a workforce skilled in operating these advanced systems. Companies have announced more than $1.7 trillion in new manufacturing investments in the United States, semiconductor fabs in Texas, EV battery plants in Tennessee. But much of this exists only in planning documents. Construction takes years, and the deeper supplier networks that make local production sustainable take even longer to mature. The World Economic Forum projects the global smart manufacturing market will reach $500 billion. PwC forecasts that by 2030, 45% of global manufacturing could be fully automated. But dark factories are not without challenges. High initial costs make deployment prohibitive for many companies. Technical failures can halt production entirely since there are no humans to improvise solutions. Cybersecurity becomes critical when entire facilities run on networked systems vulnerable to attack. And perhaps most importantly, these facilities require rock-solid connectivity that doesn't exist everywhere. The manufacturers who succeed will be those who view automation not as a cost-cutting tool, but as a strategic enabler. Those who invest in workforce retraining. those who build resilient supply chains with multiple regional nodes, rather than depending on a single global network. Dark factories represent something profound: the decoupling of manufacturing from human labor at scale. For centuries, where things were made depended on where workers lived. That equation is being rewritten in real time. The facilities operating in darkness today are just the beginning. As AI grows more sophisticated, as robots become more capable, as connectivity becomes more reliable, the boundaries of what can be automated will continue to expand. The question for all of us, workers, business leaders, policymakers, and citizens, is how we'll shape this transition. Will it create abundance and opportunity, or displacement and disruption? The machines don't care either way. They'll just keep working, in the dark. If you found this valuable, consider subscribing for more deep dives into technology and economics. Hit the notification bell so you don't miss our next video exploring how these changes will impact your industry, your job, and your future.